Welcome, everyone. Thank you so much. My name is Stephanie Ciccarello, and I'm the Director of Sustainability for the town of Amherst. Welcome to our Heat Pump Incentive Program information session. We have our presenters from CET with us this evening. I also want to let people know that there is language interpretation for both Spanish and Mandarin. If you go to the bottom of your controls, you'll see a little globe. Click on the globe and you can choose which language you'd like to follow. If you're not following in Spanish or Mandarin, make sure that it's in English. We are fortunate to be able to have this heat pump incentive going right now. This is because of ARPA funding that the town received. This program will be running until the end of 2026. And with that, I will hand it over to Marina Gallant from CET, who can tell you more about the program.
Great. Thanks, Stephanie. My name is Marina. I am the program manager at CET for this program here that we're doing in conjunction with the town of Amherst. So I will just get us started. I'll start with us as a company, as CET. We're a environmental nonprofit that have been in the environmental space for about 50 years now, serving a lot of residential, commercial, and multifamily customers as well in the energy efficiency space. So we bring a lot of knowledge of energy efficiency practices, and we're as our mission states here, wanting to innovate, implement, and scale the environmental solutions that communities need to thrive in any way we can. So I'll start with the agenda here. So we'll do a brief introduction, which I've already done, and then we'll go into our technical topics for this evening, kind of surrounding heat pumps as a whole. So why you might want to consider heat pumps, some overview of the common technology and the common terms that you might hear when referring to heat pumps, some of the common misconceptions that people might have surrounding heat pumps, and some rebuttals to that. As we get into the colder weather here, we'll kind of talk through some tips for prepping your home for winter as well. And then at the end, after you've learned about heat pumps and started thinking about it, we'll go through the program as a whole, how to get started, what the eligibility requirements are, and how you can get in contact with us. We'll end with the program impact to show you what we've done so far, and then leave plenty of time at the end for Q&A, as well as our program contact information down below. So with that, I will turn it over to our lead technical consultant, Edison Dika, who will walk us through the tech topics for today.
Right. Thank you, Marina. Hello, everyone. So why consider heat pumps? Heat pumps save money. They reduce your heating and cooling costs with more efficient technology. They also help you stay comfortable year-round, so you're able to enjoy reliable heating in the winter and cool AC in the summer. They also help you go green. They do lower your carbon footprint and help support the town of Amherst sustainability goals. Next slide, please. And next slide. So what is a heat pump? Heat pumps are an energy efficient alternative to traditional fossil fuel heating systems, such as a boiler or a furnace. They transfer heat rather than generate heat. Because of this, heat pumps efficiently provide comfortable temperatures for your home without the need of a backup system. During the heating season, heat pumps move heat from cool outdoors into your warm house. And during the cooling season, they move heat from your house to the outdoors. While a geothermal heat pump is the most energy efficient system, or air source heat, the most energy efficient heat pump, Air source heat pumps are the most common heat pumps out there. An example of a heat pump is a refrigerator. As you all know, inside your refrigerator is cold, but behind the refrigerator or underneath it is warm. So what the refrigerator is doing is moving warm air from inside and blowing it outside. That's why it's warm outside the refrigerator. Now, a heat pump is pretty much doing the same thing, but also has a reversing valve to keep the inside of the home um, warm in the winter, and it's pretty much the same technology. A heat pump is just bigger and it's applied for our homes and living space. Next slide, please. So there are three primary types of heat pumps that are recommended to homeowners. We have the air-to-air heat pumps, also called air source heat pumps. There's ground source heat pumps and air-to-water heat pumps, which are technically air source heat pumps as well. In this webinar, we'll be discussing primarily air source heat pumps. Um, Cold climate air source heat pumps are the single most recommended technology since they are the most common, least expensive, and contractors are the most familiar with them. Whether a ducted or ductless system is recommended depends on their a homeowner's current system. Next slide. So unlike all other heating systems, heat pumps do not create the heat. They just help move the heat or move the air. This is how it can achieve efficiencies greater than 100%. It uses the same technology, like I said before, as a refrigerator, a freezer, or an air conditioner. But unlike traditional air conditioning, it is capable of switching the direction in which it pumps or transfers the heat. So it can toggle between heating the house and cooling the house. Next slide. So next we will be talking about types of heat pumps. There's the ductless heat pumps, which are the heat pumps that are also known as mini splits. With these types of heat pumps, there's no ductwork needed. They are ideal for homes without existing ductwork, and it reduces installation cost and complexity. They also help with zoning. So you'll be able to zone your heating and cooling. You could have one room in cooling mode and another room in heating mode, but also not only that, you could have both in heating mode, but set the temperatures differently for each room. They are also compact and flexible. They consist of an outdoor unit and one or more indoor wall-mounted unit. And it's not always wall-mounted. They have ceiling cassettes as well, or floor or ground-mounted ones. And this makes it suitable for wide ranges of spaces. Next slide. So ductless mini splits, they have three indoor variations. As you can see, there's the wall hang, floor mount, and ceiling cassettes. They are versatile enough that you can size them to heat or cool larger open spaces or even small bedrooms or offices. There's a lot of form factors when it comes to ductless systems, starting with the wall hang unit on the left that most of us are familiar with. This can easily be hung on the exterior walls and sometimes interior walls depending on the situation. You can also get floor mounted ones that looks a little bit more like a floor radiator, um, at least in where it was set. These are becoming increasingly popular as well and are great alternative to the wall hang units, particularly for first floor heating. Then there are the ceiling cassettes, which can be mounted into your ceiling. the rectangular option in a ceiling cassette is a bit newer, and it does a better job of fitting between joists in the ceiling, which was previously an issue in terms of fitting some of the ceiling cassettes. There are new options coming out all the time to make installing this technology very practical. Next slide. So next we'll talk about the other option, which is ducted heat pumps. So these ducted heat pumps distribute heat and cooling evenly throughout the house using your existing ducts, or a contractor could install a new duct all throughout your home. They are discrete installation. Ducted systems are concealed in walls, ceilings, or attics, preserving the home's aesthetics. They also have improved air circulation, which means they enhance air circulation, boosting indoor air quality with appropriate filtration. They are also great for furnace retrofit. So if you have an existing furnace in your home that has ductwork running already in your home, contractors are able to use the existing ductwork to attach to the heat pump. Next slide. So for homes with existing ductwork, where they have existing central air, that we are able, contractors are able to use a high static air handler to tie into the existing ductwork. The caveats are that there are some caveats for this in order for them contractors to use your existing ductwork. And then for homes with no existing ductwork, we are seeing more contractors offering low static or compact ducted systems. These are also known as mini ducted units. These compact ducted units can be set up with some amount of short-run ductwork that allows you to use one unit and impact a few different smaller rooms. These can also be really handy to use in parts of the home where the bedrooms and bathroom are located, so that each room doesn't require a ductless unit. So for example, in a cave-style home, they may run ductwork on the first floor and ductless or the mini splits on the second floor with head units. Next slide. So with air-to-water heat pumps, these have the same outdoor units as a regular AC unit, central AC unit. It uses refrigerant coil and a fan to absorb heat from the outside. And yes, it's even able to do this in the winter. There's compression. So the refrigerant is compressed, which raises its temperature. And then there's heat transfer, where the hot refrigerant passes through a heat exchanger, transferring the heat into water. With the way it's distributed, it uses the heated water, which is sent into the home's hydronic system. So radiators, underfloor heating, fan coils, or a buffer tank. And then this cycle continues or repeats itself, where the refrigerant cools down, goes back outside, and then the process repeats itself. And then the heated line is sent to the hydronic system in the home. Next slide. So applications for air-to-water heat pumps, radiator upgrades. So in about 1960s houses with old cast iron radiators, a low temperature air-to-water system can be paired with slightly larger radiators or fan-assisted convectors for efficient heating. Underfloor heating, these are common in modern builds or renovations because it runs at lower water temperatures, so between 90 to 120 degrees instead of 160 to 180 degrees. It's an ideal match for heat pumps. Combination with domestic hot water, so air to water heat pumps can be combined to heat your hot water in your home as well. And typically they'll have a storage tank that can be integrated, so the same system provides hot tap water. They do also have cooling capability. So in some setups, the system can circulate chilled water through fan coil units for summer cooling. There's also hybrid systems where in cold climates, an air-to-water heat pump can work alongside a boiler. The heat pump handles most of the load, and the boiler kicks in only during the extreme cold temperatures. Next slide. So next we'll talk about cleaning and maintenance of heat pumps. We'll discuss how often you should be cleaning them and what does maintenance and cleaning look like for heat pumps. Next slide. So how often should we clean or maintain our heat pumps? Regular cleaning and maintenance are crucial for mini splits, especially before heavy usage seasons like the summer or winter. And since we are entering a winter season, if you already have a heat pump, right about this time is when you should be thinking about cleaning your heat pump. The removable filters in the indoor unit should be cleaned at least every few weeks. The frequency of cleaning depends heavily on environmental factors, such as humidity and dust levels. If the indoor unit is in a particularly dusty area, or there are pets in the house, or the unit is in a kitchen exposed to smoke, steam, grease from cooking, it may become dirty more quickly and should be cleaned more regularly. Additional cleaning for the indoor and outdoor coils can usually be done at the beginning of each heavy usage season. But it's a good idea to regularly inspect your equipment and clean it as needed. Next slide. So here, just a few main components of a mini split system. The cleaning that I just explained is for the indoor unit, the head unit up top. The bottom unit is the outdoor unit, and that should also be cleaned, but I would recommend having it done by a professional. Next slide. So the indoor unit, which is usually mounted on a wall or ceiling, contains a coil, fan, and an air filter, or air filters. Warm indoor air is drawn over the cold coil during the cooling mode, while the cold indoor air is drawn over the warm coil during heating mode. Next slide. For the outdoor unit, it houses the compressor, condenser, coil, and fan. And this is where heat is exchanged with the outdoor air during both heating and cooling modes. Next slide. The refrigerant lines or condensate lines are what connects the outdoor and indoor units. And they transport refrigerant to allow heat transfer. The condensate drain line, when cooling, it carries moisture from indoor air that has condensed on the evaporator coil to a drain or collection pan. That way, moisture is not collected right on the indoor unit, but it's able to drain to the outside. Next slide. So we'll discuss some common criticisms of heat pumps and their counterpoints. Next slide. So there's arguments about the limited heating capacity of heat pumps, and the argument goes, air source heat pumps struggle to fully heat large homes, especially in colder climates, potentially requiring backup systems. And the counterpoint here is that a properly sized cold climate rated system can provide adequate heat with or without an auxiliary system. The key here is again properly sizing the heat pump. And that's why as part of this program, we do a manual J load calculation, which is a great way to ensure your heat pump is sized correctly. It takes into account the square foot of the home and all the different components of the building shell, windows, wall, insulation, attic and basement insulation values, and it calculates the heat and cooling load of the home. This tells us and your HVAC technician how much heating and cooling your home needs, and then they can select a heat pump equipment that is a good match and fit for your home. Without a manual J load calculation, HVAC technicians are just guessing and they get it wrong many times when they guess. Next slide. And in the argument here is saying says that heat pumps are inefficient in cold weather. Um, and the counterpoint is that certain modern air source heat pumps, example cold climate heat pumps, are designed to operate effectively in temperatures as low as -13. Um, and also proper sizing and installation ensures adequate performance in colder areas. And some heat pumps actually go as low as -22 degrees. Next slide. So we are gonna discuss next how to prepare your house for winter. Um, and we'll discuss a set of easy, low-cost DIY things that you all can do as homeowners. Next slide. So the first thing to do is weatherization. You want to check and replace weather stripping around your doors. Look for gaps around doors and windows. Replace poor weather stripping to reduce drafts. Second, you want to seal gaps and cracks. So use caulk for stationary gaps around window frames, baseboards, steel plates. Use expanding foam for larger holes around pipes, wiring, or vents. And third, install or replace door sweeps. This prevents cold air from coming under exterior doors. It's easy to install with a screwdriver. Weather strippings and door sweeps typically, because of the constant opening and closing of doors, they wear out very easily. So most of the time you find them ripped or torn. So checking them regularly and replacing them as needed is a good tip to reduce drafts and heat loss. And lastly, you want to close crawl spaces, vents, and seal crawl spaces. This reduces air infiltration from under your house. Next slide. And for plumbing and HVAC, you want to reverse your ceiling fans. So turn the blades clockwise at low speeds to push warm air down from the ceiling. Second, you want to insulate exposed pipes. Foam pipe sleeves help prevent freezing in basements, crawl spaces, and exterior walls. Third, you want to replace or clean HVAC filters. Cleaning filters improve airflow and efficiency. For water equipment or hydronic heat, you want to bleed the hot water radiators. This releases trapped air to improve heat output. And then lastly, you want to test carbon monoxide and smoke detectors. This is crucial with any combustion appliance use. It's really take care of the health and safety of the home to ensure that there's no carbon monoxide poisoning in the home. Next slide. And for drainage around your home, clear gutters and downspouts. This ensures proper drainage to prevent ice dams and water damage. And you want to check the grading around your home. Make sure that the ground is pitched away from your foundation to avoid water pooling and possibly leading to leaks into your basement. Next slide. And I think I'm going to hand it back over to Marina. Thank you all.
Thank you, Edison. So I will go through the programmatic side of kind of what this program is and how to get involved. But I want to pause here first and just let you all know there is the Q&A section of this where you can put in questions directly into a chat. We'll be doing questions and answers at the end. But just while the heat pump topics are fresh in your mind, I want to make that call out. If you have any questions as we go through this, you can put those in the chat.
Sorry, just to jump in real quick, Marina. We actually have the chat feature disabled. So please type your questions into the Q&A. And as Marina said, we will answer them at the very end.
Yes, thank you for that clarification. Okay, so you've learned about heat pumps, and hopefully it got you interested in them, and then we'll kind of help you hopefully get them installed. So this is kind of what we offer through this heat pump incentive program to help you make that switch. So in tandem with the town of Amherst, CET provides a $3,500 in financial incentives to help you make that switch to converting your home fully to heat pumps. With that, you get guidance from our technical experts like Edison and others that are on our technical team that have a lot of experience with heat pumps and being in homes and kind of walking homeowners through that transition. You get support with selecting your contractor, and we kind of guide you and give you some advice of how to choose one and find one that will work the best with you in your unique home. And then we help you navigate additional incentives. So not only would you be eligible for this program and the $3,500 that is offered, but there are other programs as well, like Mass Save and others that we'll get into, and we help you navigate those as well. So to start, taking the first step, any homeowner in Amherst is eligible for this program. As long as you own a home in Amherst that you live in, you'd be eligible for this program. The first few steps to consider before fully diving in is completing a home energy assessment, whether that's through Mass Save or a different vendor. We just want to see if your home needs any weatherization work or anything just to help maximize the efficiency of your heat pump system. So like Edison mentioned earlier, a lot of the common misconceptions with heat pumps is that they're not going to work properly for your home. But if your home is properly weatherized, which means insulation and air sealing work, and you're properly sizing your equipment, your heat pump will work just as well as your existing heating system. And we want to make sure that you've done those first two steps before installing heat pumps. So how it works, after you've done those first two steps, you've done your home energy assessment, you've completed the necessary weatherization work, you'll get in contact with CET. We can get you scheduled for a heat pump load calculation assessment, which Edison mentioned earlier. That is a way for us to assess what size equipment you need. And that way you can take that and bring it to a contractor so they know what size equipment you need for your home. And then after you have that, you can feel confident knowing you know what size equipment you need. You can find a contractor, and we can help you then review the quotes from contractors. We always recommend getting a quote from at least 3 contractors, just so you can kind of see the range of what's available. You can find a contractor that you feel confident working in. You don't have to do 3 quotes, but it's sometimes nice to see an average, see if this is one is really high or one is really low, or maybe this is the average that you're seeing across contractors. So it just gives you a good average to see if this is a quote that makes sense for you. And after you found that contractor and reviewed those quotes, you would then decide who your contractor is going to be and complete that installation work with them directly. And then after that installation period is done, like I mentioned, we'd help you maximize your savings. So at that point, you'd apply for mass save incentives or other available incentives. Most of that is done kind of after the installation of the equipment. And then once you've done that, you just get to enjoy your new heat pump. That'll work year round and make you feel comfortable in your home, and you'll be on your way to being way more efficient. So our program impact, just to kind of give you a scale of where we're at, and if there's still the opportunity for you to get involved, which there definitely is. So we've done 3 completed installs. So 3 homeowners in Amherst have gotten heat pumps installed in their homes, and they have made the full switch to heat pumps. We have 8 customers that are currently in process. Either they have just completed their load calculation assessment with us, or they're trying to find a contractor, or they're having us review their quotes. They're kind of in that process and moving towards installation. We have the capacity to do 19 more installs for the rest of the program term, which Stephanie mentioned at the start of this is through the end of 2026. So we'd like for all of the installations and everything to be done by the end of November, just to give time to close things out before this program ends at the end of the year. And in total for this program, we can support 30 total installs. So we still have plenty of space and capacity if you're interested in reaching out to us and getting heat pumps installed in your home. Don't feel like there's only a few spots left, but spots are filling up pretty quickly. You can do 19 more. So definitely don't wait if you are considering heat pumps. We'd love to help you. And like I mentioned earlier, there are other incentives that you can take advantage of. So this incentive does stack with others. So it's not you can only use the incentives that we offer through this program or Mass Save. You can use them together to kind of maximize the savings that you're going to get and reduce your upfront costs. So this program, the Amherst Heat Pump Incentive Program, is $3,500 for a heat pump. Mass Save has a great incentive right now for $3,000 per ton. And ton is the term they used for sizing your equipment. So you can have a 3-ton system or 4-ton system. So it's just based on the size of the equipment that you need for your home. And that incentive is for up to $10,000. There's also the heat loan, also through Mass Save. That is a 0% interest finance loan that has terms up to 7 years, and that you can finance up to $25,000. So a lot of times people use those two, the rebate and the heat loan together. So say, for example, you have a heat pump project that's going to cost you $20,000. You would use the heat loan, for example, you'd finance, you want to finance that cost. What they would do is have you finance $10,000, and then they'll give you the $10,000 rebate. So it kind of helps reduce both the amount that you're financing and your upfront cost for getting that replaced. There is also the Energy Efficiency Home Improvement Federal Tax Credit. That expires at the end of this year, along with other federal energy efficiency home improvement credits. There's also one for solar and for weatherization work. So there's quite a few. All of those are set to expire at the end of this year. And that's up to $2,000 as a tax credit for getting heat pumps installed in your home. So if you are considering heat pumps and you're kind of on the fence, this year would be a great opportunity to do that to further maximize all of the incentives and credits that you can take advantage of to help further reduce your initial cost to upgrading. Along with this program and all of the coaching and assessments that we can help you out with, there's also a lot of great other opportunities for learning more about heat pumps and learning about how heat pumps could be a good fit for your home. But MassSave offers a no-cost decarbonization consultation. So this is where you can talk with heat pump experts and get guidance on making that switch and seeing if it would be a good fit for your home. And a lot of these you can do in tandem with this program as well. So not only can you take advantage of our technical experts and get a no-cost assessment through us, you can also take advantage of all of these to kind of further feel comfortable in making that switch and talk to others as well. Rewiring America has a great savings calculator tool, as well as a lot of helpful resources that you can go to. This is a great resource for finding out if it makes sense. So, heat pumps are a big investment. And this is a great tool to use if you're wanting to see how your current utility bills and your current heating system compares to switching to heat pumps. So you can see if financially it would make sense for you to switch. And then the Massachusetts Clean Energy Center, or MassCEC, they also have a lot of helpful resources for transitioning not only to heat pumps, but also solar, electric vehicles, and making that switch to a fully electric home. So I highlighted their air source heat pump section, but they have a lot of very helpful resources for learning more about this technology that we've been discussing today, as well as others if you're curious. A lot of people do heat pumps with a solar installation as well, so they have great resources for learning more about that and finding out what would make the most sense for your home. And with that, that is the end of our presentation here. So like we mentioned, there is a Q&A section that you can put all of your questions in. And I will end here with our contact information. So we have a website that has all of this. We'll also post these slides on there as well as the recording of this so you can watch for future reference. And that's also where you can reach out to us directly if you want to learn more. You can fill out, there's like a contact us section of that page. You can fill it out, or you can reach us by phone or email if you're interested in learning more about this program and how to get involved. So with that, I will turn it back over to Stephanie to see if we have any questions.
Thank you so much, Marina. We are so lucky to have CET as our program administrator. So I have several questions, and I will start with the first. This one is asking about the 4 cent per kilowatt hour discount on electric rates that starts in November. And who do you need to contact to get the discount? So that would be through Eversource, the utility provider. They are offering a discount if you have a heat pump on your delivery rate. I'm specifying this because it does not affect whether or not you are part of an aggregation or get solar or anything. As long as you are an Eversource customer and you, I've been told, have even a single heat pump, you will be eligible for that discount. However, you need to contact Eversource and apply to get the discount. So please be sure to contact Eversource directly. I've been told they may not have the program up and running quite yet. So if you contact them and don't get an answer immediately, please be persistent and keep trying, because they should have the information fairly soon and the program should be up and running by November. The next question. How are the filters cleaned for the indoor units?
I can take that. So for the indoor units, there's a panel that pops up, and there's usually two filters, and they just slide right out. You could vacuum the dirt out of the filter. They are reusable filters, so you could vacuum the dirt out, or you could wash it. If you do decide to wash it with water, you have to wait for it to dry before replacing the filter back. So for those who will be washing them, we highly recommend purchasing an extra filter. That way, while the one that you took out to wash is drying, you could put the extra one in. That way you don't have to wait or have the heat pump off during that period of time. And one key thing is before you do any cleaning, to turn the system off.
Thank you, Edison.
Welcome.
Next question. Do I need to get a Mass Save audit to qualify for the rebate? I live in a condo and I'm considering replacing my AC unit with a heat pump that's rated at 2.4 tons. How much would the rebate be on a 2.4 ton unit?
Yeah, so for Mass Save specifically, yes, they do require you to have a home energy assessment, just because they want to see if you have any opportunities for insulation and air sealing work. Again, just to kind of maximize the efficiency. They don't want you to put in a heat pump. You don't have any insulation because then your heat pump's going to be working harder to keep it comfortable in your home. But it depends on, there's kind of two rebates for this program and for the whole home heat pump in Mass Save. They do require you to complete weatherization work to again maximize the efficiency. But if you're just looking at one heat pump, Mass Save does offer a partial heat pump rebate. Both of those are per ton, so either the partial or the whole home rebate as a per ton. I think it was 2.4, you said. Was that the
Yes.
correct tonnage? That's if you're doing the whole home and you're fully converting to a heat pump, and no longer using your existing system, that would be it's 3,000 per ton, so it'd be about 6,000, slightly more with the 2.4. Partial is going to be less, and that is, I want to say,
1250 per ton.
1,250, yeah, 1,250 per ton. So you'd be looking at less, but it just depended on if you're doing just one heat pump system, or if you're looking to fully convert.
Thank you. Next
And
question. Oh, sorry, go
if
ahead,
I could
Deacon.
just, if you are going whole home, then you have the whole home rebate from Mass Save, and then the Amherst rebate will be on top of that, or the Amherst incentive will be on top of the Mass Save.
Yes. Yeah. So you'd be looking at 6,000 or so from Mass Save. And then if you're doing a whole home conversion, another 3,500 from the Amherst program. So 9,500 in total. If you were doing just a partial and not looking to fully convert, it would just be the Mass Save rebate at that 1250 per ton. Currently with this program, we're only doing whole home conversions. So you'd have to look at fully converting to heat pumps in order to get this incentive.
Okay, I think you just answered the question, but I'll ask it again anyway. Is the 3,500 in addition to the Mass Save rebate?
Yes. Yep, you can do both. So if you can qualify for the full $10,000 for Mass Save, if you're doing a whole home conversion, you'd also get another 3,500 from this program. So you get 13,500 total.
Next question. What is the efficacy of the mini split system in heating and cooling areas in their home, i.e. stairways, foyers, etc., where there is no mini split? The splits are likely to be in rooms.
Yep. So I'll try to answer that. So when the mini splits are designed, they design the placements of the mini splits so there's a large coverage area. So let's say the mini splits are up the stairs or in a bedroom area. There's 3 bedrooms upstairs. Um, the warm air from the living space from the first floor is gonna naturally rise up those stairs, and also the air movement from the unit placements in the 3 bedrooms is also gonna come together to keep all the common areas stairwells efficiently heated and cooled.
Okay, next question. I contacted Mass Save recently and they said I didn't need an energy audit because I live in a condo. Are you familiar with the requirements of condos versus houses?
Yes, it depends on the condo. But typically, the way Mass Save labels a condo, you would be eligible, but it depends on how the condo is structured. If you want to reach out to us, we can definitely take a look at your situation and see if you would qualify, either for this program and Mass Save. Sometimes it is very dependent on the condo layout and how many buildings there are and if there's units attached and everything. So definitely reach out to us and we can take a look at your unique situation and see what you'd qualify for.
Okay, next question. Edison said heat pumps save money. What is the source of that statement? Are there empirical data demonstrating that homeowners save money on energy costs, especially during the winter, for example, compared to heat from natural gas?
I would say specifically compared to heat from natural gas, the cost savings may not necessarily be there, just because of the price per term for natural gas compared to the price per kilowatt for electricity. However, heat pumps do help with carbon savings. Um, Natural gas, because it's a fuel and has to be transported to your home. Um, it's not good in terms of its carbon footprint. Um, Heat pumps paired with solar or heat pumps on their own do help with carbon savings. So if you're trying or want to decarbonize, um, definitely heat pumps are the way to go. But if it's um, dollar cost savings, natural gas is comparable to heat pumps. There are certain temperatures where heat pumps are not as efficient, where natural gas will be more will save more in terms of the dollar. But for the most part, in terms of when temperatures are in the low 30s, heat pumps work more efficiently and save on cost.
Okay, and I think, let's see. We currently have a hybrid system with mini splits and oil heat backup, but have run into an issue trying to find a thermostat that will actually integrate the two systems. We've been told by the company that installed our heat pump that manufacturers are no longer producing thermostats that can perform this integration. Have households you've advised run into this problem?
Um, I'm not too sure what your current setup is currently. But if it is that you have mini splits paired with boiler, an oil boiler, then yeah, there is no real thermostat that will integrate the two. But if you do have a furnace, um, an oil furnace that has the heat pump integrated, then you have one thermostat that will naturally um, integrate the heat pump and the oil system. So it really depends. A mini split won't be able to communicate with your oil boiler easily. you need some softwares and some smart home systems to be able to get it to work that way.
Next question. Does the deadline for the federal tax credit mean that the system has to be installed by then or just be in process by 12/31, December 31st?
Good question. I believe it has to be installed in this calendar year.
Yes.
Okay, and next question. Is the temperature for the heat pumps adjusted overall for all rooms at the same time? Or do individual units in each room have their own temperature adjustments?
For mini splits, individual units can have their own temperature adjusted. For central ducted heat pumps, it'll work as a regular central fossil fuel system, like a boiler or furnace, where you have one central thermostat controlling the entire house. But mini splits, the beauty with them is that you could control each head unit separately and set those temperatures separately.
This looks like the last question. When evaluating a heat pump, should I be more concerned about the SEER2 rating or the HSPF2 rating? How do I know if a higher SEER2 rated heat pump is worth the extra cost?
So the SEER rating 2 has to do with the cooling side of the heat pump, and the HSPF has to do with the heating side. So both of those numbers are important. However, the MassSafe has a whole list of qualified products list where you could kind of double check whichever equipment that your contractor proposes. You could double check to make sure that that equipment is listed on the qualified products list. And if you reach out to us and go through this program, we also help you make sure that the proposed equipment is efficient enough for to work in our climate and for your home.
Okay, I believe that was the last question. So I'd like to thank Edison and Marina for their presentation this evening. I'd also like to thank Jan, Maria Camilla, and Robinson for translation services. Again, the program runs until the end of December 2026. The federal incentives are up at the end of this year, December 31st of 25. So please be sure to call CET as soon as possible if you're interested in this program to take advantage of all the incentives that you can now. This presentation will be recorded, is recorded, and will be posted on the CET website as well as the town's YouTube channel. So thank you all for coming. If you have any more questions, feel free to either send them to me at Town Hall or you can contact CET directly. Thank you all so much. And with that, I will wish you all a pleasant evening. Thank you.
Thank you, Stephanie, and thank you all. Good night.
Thanks,
Night.
Stephanie. Thanks, Edison. Thanks, everyone.